My name is Johnson Dobe. I'm a member of Group 8, and we choose the topic Machine Learning for Personalized Education, Optimizing Learning Outcomes Among Diverse Online Learner Population in Ghana using reinforcement learning. Taking you straight to our introduction, we have realized that there is a rise in online learning, and this online learning presents opportunities, accessibility, and flexibility. And in how much these opportunities come, it comes with challenges as well. And this go with the effectiveness for diverse learners. So we've realized also that in Ghana, there is one size fits all model struggle to meet varied learners. So in our research, we realized personal learning is one of the best model to use because it helps learners to adapt content, method, and assessment to individual needs. In doing this, machine learning also comes in because we realize it enables personalization by analyzing learner data to guide tailored interventions. Ally 2019 said that expansion of online learning platforms globally represents both opportunities and challenges for educational system. And just this to support what I've said. And also means 2010 also said that in Ghana, the increasing adoption of online learning necessitates the closer examination of pedagogical approaches that can cater to varied needs and backgrounds of its learners. Traditionally, these one-size-fits-all online education models often fail to address the unique learning styles, space, and prior knowledge of individual students, which potentially lead to disengagement and suboptimal learning outcomes, particularly among diverse populations. So with this, we move to our problem statement. We've realized despite all the potential the machine learning bring online, its application within the specific context of diverse learner population in Ghana remains largely underexplored. And there are problems faced by online learners in Ghana, which include levels of digital literacy, difficult access to technology, language issues and cultural background, and poor educational experiences. And these are important when selecting the right approach to machine learning personalization. So the current research often lacks specific insight into how machine learning algorithms can be effectively adapted and implemented to address this new problem and optimize learning outcomes in the context. So with this, we come to our goal, that is to explore machine learning-based personalization approaches that enhance learning outcomes for diverse online learners in Ghana. So with this, I will hand over the rest of the presentation to my colleagues to take over from me. Thank you.
All right, let's move on to the next slide. So my name is Richmond Ejare, and I'm presenting on the methodology. So our machine learning framework for personalized online learning in Ghana. The approach we used was a qualitative research using machine learning framework. And the machine learning model highlights reinforcement learning, adapts to student skills and behaviors, trained on learner data. And the key techniques used were the deep learning, RNN for learning path optimization, Markov decision process with Bellman algorithm for resource recommendation.
So we next slide, please.
So our approach to creating personalized online experiences for Ghanaian students leverages reinforcement learning. We are building a machine learning model that learns from student data, their background, engagement, and performances to recommend the most effective learning paths. So by using techniques such as skill deep learning and the rest alongside the Markov decision processes, our system can dynamically adapt and suggest resources that maximizes student success. Crucially, we've carefully pre-processed our data from the Open University Learning Analytics data, that is the ULAD, to ensure its relevance and applicability to the unique Ghanaian context, addressing potential sampling biases and accounting for local factors like internet traffic and mobile usage. So please go back to the previous one. Yeah, so
This
our
one or
data
this?
preparation. Oh, that's
Okay.
yes, this one, yeah. So our data preparation and experimental design. So with our data cleaning, our first step is to impute missing values. The next one is to remove duplicates and correct inconsistencies. The next one is to treat outliners. The next one is smooth time series engagements. So with our data splitting, we are using 60% for our model training. And with the validation, we are using 20%. And we are using 20% for our final evaluation. So I'll hand over to my colleague to continue.
All right, so I'm Vincent, and I'm talking about the reinforcement learning framework that we used. Now, the objective was for us to understand how the model will be personalized, and we felt that using reinforcement learning through the Markov decision process will be a perfect process. Now, for the MDP, which is the Markov decision process, there are certain components that we looked at. We looked at the state, that is where the learner's knowledge is. I mean, the level of his skills, the level of his knowledge, and then the progress by which the learner will make by its engagement with the system. And then we also looked at the actions that the learner will take, and then also the recommended actions that the system will give onto the learner in order to transition the learner to the next level or the next skill of his or the next skill, the next intelligence or the next level of skill. And then the R, which signifies the reward that the system will give to the environment or to the learner after he had completed certain processes. And then we looked at certain factors that will be discounted that talks about the ways future versus the immediate rewards. Now, the future rewards talks about what the learner will get after he has finished with maybe the process of learning. And then the immediate rewards talks about the immediate reward he gets after he had completed a specific course or a specific subject. Now, the state representation, which I've already talked about. Please, can you go to the next slide?
Okay.
Can you go back, please? All right.
Okay.
So no, yeah. So we looked at the reward function that will be able to interact. So the reward comes as a result of the interaction between the system or between the agent and then the learner. Now, the reward is given as a result of a feedback that is gotten from the learner. So it is based on the gain or the learning gain, the engagement, and the progress toward a goal or towards the goal that the system was set for the learner. And the agent will then learn from the learner by maximizing expected cumulative reward. Now, it is in this process that we move on to the value function. Now, the value function has a particular formula, so that is a formula, and then the formula talks about its state, the value from the state to its value function, and then also to the action value. All right, and then we then also used Berman equation as a resource point in order for us to understand. Please, can you go to the next slide? All right, so looking at the optimal policy, the optimal policy is represented by pi. So it is pi star with the state of the learner, which maps onto the maximum output of the system, which is the action, the value action that the system will interact with the learner and then give the expected reward over time. All right, so basically, this is what the system will be doing. It's all about the system learning with the environment to understand and also to project the next skill for the learner. Okay, the next slide. Then I leave it to. All right, so there's a simulation training that we, previously my colleague talked about 20% for tuning and then 20% for evaluation. So the 20% talks about how the system will be tuned to understand how the learner will be able to move from one point to the other and then also receive a reward. So it will look at the student profile and then the state of his mind, and it will use greedy algorithm to be able to select which path the student is supposed to take and then proceed with the student. So I think that is it for now. I will allow my colleague to also continue with the coding and the data that we had. So
So for the coding aspect, we use Python with machine learning and Q-learning to be able to achieve our targets. Right. So for the coding aspect, we started by importing a few libraries that help us to do our analysis. So we had NumPy, Pandas. Then we have those libraries help us to do the analysis on our data sets. Then we use random and matplotlib to help us with the plotting. So we use 3 data sets. That's students info, the courses, and the assessment. So these are the data sets that we use in achieving, in training our doing our machine learning. So first of all, we assign profiles to each student, whereby we have those with higher educational qualification. We have
Richard.
Okay. So then for the profiles, we set up several profiles for the learners. We have the ones with higher educational qualification. So students with higher educational qualification, that means they'll be handling more assessment-based orientation. We looked at people with disability. Um Yes, yeah, Mr. Tickets. Right. Then we have students with disability. That means they'll have more visual. Then we have the gender-based one. Then we came to have the set type actions on our video, text, and our quizzes. Then we came to write our Q learning training loop, whereby we try to loop through the various students with the course and the assessment that the person is going to handle. Right. Came to, based on this assessment, we try to, that will let us know whether the students, more of them are going in for the visual learning or the assessment based. Then we came up with so we did everything in the collab research, whereby we did our collaboration there. Thank you. So I hand over to the next person. So Joe.
Good evening. So my name is Joseph Asantambila. So I'll be looking at can we go to the recommendation? I'll be looking at the recommendation aspects of our work. So the comprehensive personal learning system could integrate these approaches. For instance, supervised learning models could permit the immediate outcome of a learner engaging in a specific resource, whilst what we chose, the reinforcement learning agency, this prediction as part of its rewards function to guide the long-term path generation. Collaborating or content-based filtering could inform the set of potential actions available to the relearning agent or provide initial recommendation before the learner data is available for purely model based approaches. So this mathematical farming provides a structured approach to develop a machine learning model for personalized education, allowing for the predictions of learning outcomes and the dynamic generation of adaptation learning path tailored to the direct need of online learners in Ghana. This specific choice of the supervised learning algorithm that we choose, that the RL techniques, state and act based and rewards functions will be critical design decision guidance by characteristics of the learning environment and the available data. So its interpretation and implementation from what we do, from what we did, all our findings, all the things, and then the work we went through. These findings demonstrate the utility of reinforcement learning in the online education platform, so that by modeling students' performance and learning progress as a mark-on decision process, educational content can be dynamically optimized to suit individual learners' needs. This is particularly relevant for we in Ghana here, our online learning landscape, which will help us a lot because the reinforcement learning is one of the best aspects that will be something that where learners derives required personalized support mechanism. They will also look at the LMS integration as the recommended models that the personalized learning system can be integrated into existing learning management system, just like ours in GCTU here. Our learning as recommended models through this approach. What we use now by what GCTU rise from undergrad to the master's program and then the PhD level. The API based integration, which is the RESTful API endpoint, allowing the machine learning system to receive learner data and return recommendations. So if this one is integrated into it, then with the web hub implementation for real-time event processing, plugging in some architecture like the model learning, enabling deployment across different learning platforms, LMS platforms common in Ghana here will also help. And the configuring components that adapt to varying institution needs, lightweight implementation option for resource environment. Then we look at the data synchronization. So offline first architecture which synchronize capability. Also the batch processing option for limited connectivity environment. More so the data compressing techniques to minimize bandwidth requirements. These and many more. This particular integration approach acknowledge the heterogeneous technology landscape in Ghana educational institution, where various LMS solutions may be developed with different level of technical infrastructure. So this is the findings and the work we did, and we recommend this to be used, and then we'll advise the school to put it and then inculcate it into their system to see how best it can help the school. Thank you very much for our presentation. So this is the end of our work. So we are sending this with all the references are down and then the main work as well.
Sorry,
Thank
can
you
I
very
talk
much.
about the results?
Yes, I'll conclude and then we end the presentation.
Oh, yeah, all right.
Yes, this kind of Gardner way, when it comes to reinforcement learning, optimizing online learning outcome in Ghana using reinforcement learning is a promising approach to address challenges like lack of internet access, device availability, and digital literacy. Reinforcement learning can personalize learning by dynamically adjusting to the content, pace, and then feedback based on the student or individual needs and progress of the learner. This can boost engagement, identify risks for the learners, and then potentializing and then also allocating resources. However, the success of reinforcement learning will improve infrastructure, comprehend teaching learning, and then commit to ethical AI practices that ensure fairness and then cultural reliance for Ghana's diverse learners. Reinforcement learning offers a powerful ideas for innovations in our education system in Ghana, especially when it comes to the online environment. Adapting to individual learning is very key in this case, and then the needs to as well. Optimizing learning pathways for the learners is very key looking at online learning. However, its successful implementation will address existing infrastructural challenges, investing into teachers and then capacity building, ensuring ethical AI practices too as well. Then the potential for reinforcement learning is to unlock the full potential of Ghanaian online learning and then to achieve educational landscape. So, like my brother said, the references of our documentation is in the document below. So, I think this is the end of the presentation. Thank you.
Okay, thank you
Yeah.
very much. So that's the end of our work.
All right, so I think we are done. So
Yeah. Yeah.
JD, cut the recording.